Okay, so you're asked to estimate the area under this graph using just two rectangles of equal width on the interval from 1 to 5. Okay, uh, so this is pretty simple in that we're not trying to generalize this to have infinitely many rectangles. We're just going to estimate the area. So delta x is the length of the interval divided by the number of rectangles, which is 2. So 5 minus 1 is 4. 4 divided by 2 is 2. And that indeed is the width of the first rectangle. And 5 minus 3, this distance is also 2. That's delta x. Now you're asked to use the midpoint of each interval to find f of that number in order to find the height of that rectangle. And then when we find that number, in this case, it'll be 1 times 2. The area of this first rectangle is 2. Now, how do you find the midpoint? Well, you could just figure out if I start at 1 and add on 2, I end up at 3, and the midpoint of the segment with endpoints 1 and 3 is 2. Another way to think about it is if I start at the left-hand endpoint and don't add on any widths, I start there at 1. And then if I start at 1 and add on 1 width, I'll get this endpoint, which is 3. And so if I add those together and divide by 2, I've got the x coordinate of the midpoint. And similarly for x sub 2, you could follow a similar pattern, but this midpoint is 4. And now if we want to find the area of each rectangle, it's f of x sub 1 times the width of each rectangle. So if I put x sub 1 into f of x, I'll have 2 minus the cosine of 2 pi. Cosine of 2 pi is 1. 2 minus 1 is 1. 1 times 2 is 2. And that matches what we had over here in our picture. And following a similar pattern, if I put 4 in for x sub 2 into the function, I'll have 4 minus the cosine of 4 pi, which is 4 minus 1, which is 3. 3 times 2 is 6. And if we add these two areas together, that's our estimate. Turns out the true area is 12. So this didn't give us a very close approximation, but if we increase the number of rectangles, we would get closer and closer to the true value. And you'll find out eventually that we take the limit as n approaches infinity, where n is the number of rectangles. Okay? And that's what we mean by the definition of a definite interval. There you go. Hope that gave you some idea for problems similar in the future. If you have any questions, post a comment.